So what we want to look at today is the greatest common factor and factor by grouping. So let's start with the greatest common factor, and we want to look at some of the rules for greatest common factoring. And then once we get those rules and everything, we will then go to how we need to use them and everything. So the first thing that we want to do is we want to look at the numbers and find the number that will divide evenly into all other numbers. Hint here, look for the largest number that will divide evenly. Okay. Second, we want to look at each variable separately. Find the smallest number of each variable that is in all terms. These items will give us the greatest common factor. And what we're going to do is we are going to divide each term by the greatest common factor to get the what we call leftovers. We want to place the greatest common factor outside the parentheses. Then place the leftovers inside. Okay, so these are the couple of steps that we're going to follow and how we're going to do it. So let's look at what this looks like in an actual example. Okay, so for example, if I start off with 6w plus 18. Well, my first step is to look at the numbers 6 and 18. And I want to know what is the largest number that will divide evenly into both of those. Well, I have possible factors because 2 will go into each one of them, 3 goes into both of them, 4 doesn't, 5 doesn't, 6 goes into both of them. Oh, can I go any higher than 6? No, because 6 is one of my numbers. So here's one key fact is that your greatest common factor, let me make that smaller, so that your greatest common factor can only be as large as your smallest number. Okay, so 6 is the largest possible factor that we have for both of these numbers. And notice that 6 does go into both of them. So my GCF that I'm going to look at is going to have 6 because it's my largest number that will go into both of these. Then I look at my variables. I have a variable with a w. Well, do I have a w in both of my terms? No. So I cannot divide out a w. It has to be in both of them. So my greatest common factor in this problem is just a 6. So what we're going to do is we're going to put the greatest common factor on the outside, and then we're going to basically come up here and divide both of these by a 6. Well, 6 divided by 6 is just 1, and I still have my W. And then a positive 18 divided by 6 gives me 3. And I could leave it with 6 times 1W plus 3, or you can write it 6 times W plus 3. Either way. The key is what is on this line right here must be equal to what's on this line. That is why it is very important that we put our greatest common factor here. So I can always come over to the side and check myself. I have 6 times W plus 3. Remember, whenever we were multiplying, we distributed this 6 back in here. And so that would be 6 times W, which gives me 6W, and then 6 times 3 gives me 18. Does that give me what I started with over here? Yes, it does. Therefore, this is factored form with my greatest common factor here. Now, I could have factored out only a 2 or my 3, but that would not have been my greatest common factor. Let's look at another example of this, and let's look at if I have 21 m to the third minus 7m. Okay, well, first thing we do is come over to the side and we look at our possible factors for our numbers. So let's see here. Possible factors for our numbers. Well, 7, the only factor for it is 7 and 1. We know that 1 goes into everything, so we don't really count 1 as a greatest common factor. But will 7 go into 21? Yes. So 7 is actually my only possible factor. Then what I want to do is I want to look at my m's. Okay, let me rewrite this and see if this helps you. 21 is the same thing as 7 times 3, and then I have 3 m's. 7 is 7 times 1, and then I have an m. Notice I've got a 7 in both of them, and I also have 1 m in both of them. Therefore, my greatest common factor is going to be a 7m. So I'm going to put that on the outside of my parentheses. And I'm literally going to divide both of these by a 7m. And so notice what happens is the 7's cancel and one of the m's cancel here, leaving me with a 3, and I still have 2 m's here, so that's m squared. Now then, a negative 7 divided by a positive 7 leaves me with a negative 1, and my m's canceled, so I'm just left with a negative 1. So I'm showing that I have 7m times 3m squared minus 1. I do have to put this 1 here because I have to have something for this 7m to multiply by. Let's come over to the side and check. I have 7m times 3m squared minus 1. If I distribute this, that gives me 7 times 3, which is 21, and then this m times m squared, that gives me 3m's, or m to the third, and then 7m times a negative 1 gives me a negative 7m, which is what I started with. Therefore, I have factored this correctly using my greatest common factors. Let's try another one with greatest common factors before we move on to factor by grouping. So if we start with 50 x squared y minus 40 x y squared plus 10 xy. Okay, so let's first look at all three numbers. We have 50, we have 40, and we have 10. Well, we know that 2 will go into all of them. We know that 5 will go into all of them. But the greatest number that will go into all of them is actually 10. So our greatest common factor is going to have a 10 in it. And I'm going to rewrite this so that I know that that's 5 times 10. And this x squared is 2 x's and a y. This 40 is 4 times 10. And this is x and 2 y's. And then this 10 is a 10 times 1. And I write the 1, that way I remember that I have to have a 1 whenever I put it down into my final answer. And an x and a y. So notice we have a 10 involved in all three of them. What else do we have involved in all of them? We also have an x that's common in all of them. And we have a y that's common in all of them. So my greatest common factor is actually 10xy. So I'm going to come down here, and I'm going to put 10xy because that's my common factor on the outside of the parentheses. And I'm going to divide each one of them by a 10xy. So let's see here. My 10's cancel, an x cancels, and a y cancels. A 10 cancels, an x cancels, and a y cancels. A 10 cancels, an x cancels, and a y cancels. So we're left with, in this first term, a 5 and an x. In the second term, we're left with a negative 4 and a y. In the third term, we're just left with a positive 1. And remember, I have to put something for each term because I have to be able to distribute this number back in here and see if I get what I originally started with. So I'm going to come off over to the side and check myself. 10xy times 5x minus 4y plus 1. So that's 10 times 5, which will give me 50. X times x gives me x squared, and I have a y. 10 times a negative 4 gives me a negative 40. I have an x, and then y times y gives me y squared. And then 10 times 1 gives me a positive 10, and then I have an xy. So I did end up with what I started with if I multiplied it back together. So this is my factored form. So we have factored out our greatest common factor. And it's important to know that the very first step, no matter what we do, is to factor out your greatest common factor in all of these. Okay? Now what we want to discuss is factor by grouping. So when we're talking about factor by grouping, we're talking about mainly starting with 4 terms. So factor by grouping, we usually want to start with 4 terms and go from there. So the first step is, in any factoring is going to be to factor out the greatest common factor. Factor out your GCF. Okay? The second step is to group the four terms into sets of two. Then from each set, factor out the greatest common factor for each individual set. Hopefully, once the greatest common factor is factored out, from each set, then the leftovers that are in the parentheses will be the same. Therefore, factor out the leftovers and place the greatest common factors in a set of parentheses by themselves. Okay? So these are the steps that we're going to follow when we factor by grouping. Sometimes we have to rearrange our factors, but most of the time we can factor them as is. So let's start with some examples. And let's see. If I start with, let's see here, 8a squared minus 4ab plus 6ac minus 3bc. So the first thing I do is I want to see, is there a number that will divide into all four of these numbers? No, because of this 3. These three numbers can be divided by 2, but this one cannot be. Then, so there's no common number to put in all of them. So then I start looking at the variables. Is there an a in all of them? No, there's not an a in this one. Is there a b in all of them? No, there's not a b in this one or this one. Is there a c in all of them? No, there's not a c here or here. So for this one, there is no GCF. So that means I'm going to group them into pairs. I'm going to group the first two together and then the second two together. And I'm going to look at each pair individually. So looking at the first pair, I want to look for the greatest common factor of 8a squared minus 4ab. So if I look at the numbers here, 8 and 4, my greatest common number or factor is going to be 4. And then I also want to look at the variables. So if I rewrite it, this is going to be 4 times 2, and then in 2 a's. This is going to be a 4 times 1, an a and a b. And if I notice, I've got an a in both of them. So my greatest common factor is 4a. So that means I'm going to take the 4 and an a out of each one, which will leave me with a 2a minus 1b. Those are my leftovers here. I do the same thing for the 6ac minus the 3bc. number that will go into 6 and a 3, well, that number is going to be 3. And then I look at my variables. So I've got a 6a times c. Whoops, I need to put that as 3 times 2 ac and a 3 times 1 bc. And I'm going to put a positive there because we had a plus in between. And let's see here, I have a 3 in common, and I also have a c in common. So my greatest common factor is going to be a 3c. Now here's the key. Whatever sign this is right here, that's the sign that you're going to take. Okay, so if it were negative, we would take a negative, which that gives us a little bit of problems back here, and we'll do one of those in just a moment. So then I'm going to look at whatever my leftovers are. I took the 3 and I took the c, so that leaves me with a 2 and an a. I took the 3 and I took the c, so that leaves me with a negative 1b. Now, as I said before, hopefully, if this works out, our parentheses, our leftovers, will be the same. 2a minus 1b, 2a minus 1b. They are the same. So, what happens is whenever I look between this term and this term, my parentheses are actually what is common. So here my greatest common factor is my 2a minus 1b. And so I'm going to factor that out as 2a minus 1b, and then I'm going to put my leftovers, which is a 4a plus 3c, in the second set of parentheses. And I can always check myself because I can FOIL these together, multiply them together, and see if I got what I started with. So if I come over here, 2a minus 1b, let me rewrite that, 2a minus 1b times a 4a plus 3c. And if I multiply this, that's saying I'm going to take 2a times 4c, which is going to give me an 8ac. Then I'm going to take 2a times a 3c, which is going to give me a 6ac. Then I'm going to take a negative 1b times 4c, which is going to give me a negative 4bc. And a negative 1b times a positive 3c, which is going to give me a negative 3bc. Now this looks a little bit different than what I started with. The thing is the middle two terms are switched, and remember, with adding and subtracting I can rewrite those. So I do end up getting what I started with. So this is my factored form when factor by grouping. Let's look at another one of factor by grouping. If I have, let's see, if I have 5x squared plus 30x minus 2x minus 12. Now looking at this, some of you may start to combine like terms, but when we are wanting to factor, leave it as is, okay? If we start with 4 terms, just leave them with 4 terms and go from there. Is there a number that will divide into all 4 of these numbers? 5, 30, 2, and 12. Unfortunately, no. Is there an x in all of them? Unfortunately, no. So that means that I don't have a greatest common factor to pull out, and I'm just going to start with my factor by grouping. So I'm going to group the first 2 terms and I'm going to group the second two terms. So in my first set of terms, the 5x squared and the 30x, I try to say, okay, what number can I put in there? And I can divide both of those numbers by a 5. So I'm going to rewrite that as 5 times 1, x and x, plus a 5 times 6, and an x. Okay? So that means I'm going to take out a 5, and there's also an x in both of them. And then I'm going to put my leftovers of 1x plus a 6. Now looking at the second set, a number that will go into both of them is a 2. So I'm going to rewrite this as a negative 2 times 1x and a negative 2 times 6. And remember on the previous problem I said whatever sign this is, that is what I'm going to take. So I'm actually going to have to take a negative 2 out of here. When I do that, that takes this number and it takes this number. So that leaves me with a 1x, and it actually leaves me with a positive 6. Because it's the same thing as I'm dividing this negative 12 by a negative 2. Negative divided by negative gives me a positive. So now I look and say, okay, are my parentheses the same? Yes, they are. So I'm going to pull those parentheses, which are my leftovers, to the front, and take my greatest common factors, my 5x and my negative 2, and put those in my second set of parentheses. And I have factored this problem. Now let's look at one where we have a greatest common factor prior to the actual factoring process. Let's look if we have six AB squared minus 18AB minus 6b to the fourth plus 18b to the third. Okay, so looking at this problem, the very first thing we want to do is we want to say, is there a number that will divide into all three of these numbers? Yes, there is, and that number is 6. So I'm going to take 6 times 1, a, and 2 b's. 6 times 3, a and b. 6 times 1, and there's 4 b's here. And then a 6 times 3, and there's 3 b's here. So if you notice, there's a 6 in each one of these, but there's also a b in each one. So we're going to actually take out a 6b to begin with. And that will leave me with a 1ab minus 3a minus a 1, and I've got 3 b's here, so b to the third, plus a 3b squared. Okay, I've taken out the greatest common factor, the 6b. And what's going to happen with it is it's just going to follow me all the way down. So it'll be on my next step as well. Then what I'm going to do is I'm going to look at the first set of terms. Is there a common number between 1 and 3? No, but there is a common variable. Notice there's an a in both of those. So I'm going to have to take out an a, which will leave me with a 1b minus 3. Then I'm going to look here. Notice I have a negative sign, so I know that it's going to be negative, whatever I take out. And if I look here, that is a 1 and 3 b's, and this is a 3 and 2 b's. So actually I have 2 b's in common, so that's going to be b squared, leaving me with a 1b. And since I changed this sign, I changed this sign to be minus 3. And it's important because if I don't change that sign, my parentheses will not be the exact same. Are my parentheses the exact same? Yes, I've got a 1b minus 3 and a 1b minus 3. So again, my 6b follows us down. Then I'm going to have my parentheses, which is 1b minus 3. Then I'm going to put my leftovers, a minus b squared, in the last set. And so now I have this problem fully factored out. It had a greatest common factor, and then it had factor by grouping. Now if you do the factor by grouping first, that is fine. You just have to remember to look for a greatest common factor in one set of your parentheses at the end. So what I want you to do is I want you to practice some factor by grouping and greatest common factors, because these are going to be important when we get into the next set. Let me know if you have questions.